So what we're doing today is just kind of an exercise with Hooke's law. I didn't have really time to do it earlier. I wanted to make sure that we were going to get through the whole unit in the right amount of time. So we're kind of coming back to it now just because we have the time. So it's just a little kind of mini lab activity. You're not handing in a lab report or anything here. I don't even have the Chromebooks for you to put the spreadsheet together. Okay, we'll kind of just look at that on the board here together with some of our class data. So what we're going to do is we're going to set up a Hooke's law apparatus like the one you see in the picture here. Okay, so each one of these boxes has exactly what you see in the picture. Right? It's got, where that spring came from. Okay, it's got a stand, and it's got a spring, and it's got like a little ruler deal. Okay, on the spring. So all we're going to do is hang different amounts of mass from our spring. Okay, so you just have to hook the spring through this little hole on the weight stand. Okay, like so. Okay, and we can easily measure how much we stretch the spring by. Okay, so that's what we're going to. That's what we're going to be measuring. We can't actually measure the length of the spring, so that's what we'll do. Okay, this will be our like unstrained length of the spring. Okay, when just the stand is hanging from it, and then we're just going to add mass to it, right? And we'll be able to calculate the force. I may need to tighten those a little bit. Okay, and we're just going to calculate the force of gravity that's pulling on the spring. How will that tell us what the force in the spring is? If gravity is pulling down on the spring, right, the spring is pulling up with the same amount of force because it's not going to be moving, it's not going to be accelerating. We're just going to put it on there and make sure that it's not oscillating too much, okay, and record our numbers. All right, so if you can, just on a sheet of paper, it doesn't have to be anything fancy, okay, just put in your force applied, mass times gravity, and your displacement. Okay, what we're hoping to get out of this is a nice linear function, because that's what Hooke's law says should happen, right? The restoring force should vary linearly with displacement, okay? And get the spring constant of the springs. Okay, everybody with me on that? Yeah? So, if you guys can get into, just small groups, because we got quite a few of these. Right, and grab yourself one box for the Hooke's law apparatus. Oh, sorry, let me show you how the slotted weights work here. Okay, so each one of these little plastic green boxes comes with a set of slotted weights. Okay, so they go on over the hook, but of course they don't fit on this one. So, guess what? We won't be using that little silver one. I forgot all about that. Okay, so you're going to take all the slotted weights off of here. Okay, which involves putting it up on the hook because that's where it's narrow enough for them to come off. The weight, or the mass, sorry, is written on each one of these little slotted masses. Okay, and this first one has a mass of 50 grams. Arms are getting shorter, I've noticed. Okay, so what you're going to need to do is just put the spring on there and get its unstrained length when there's 0 on it. Then hook the 50 on and then kind of go from there. Okay, I would say don't add huge amounts of weight because even that 50 stretches that spring pretty far. Okay, so you'll have 0 and then you'll have 50 and then add small stuff, add in small increments. Okay, let's say add in small increments another 4 masses on there. Okay, but yeah, like I say, pick the small ones because if we add too much, we're going to overstretch that and get past our ability to measure it. If you get past that, you've got too much weight on it. Okay, and it'll overstretch the springs. Okay, so I want you to collect your data for right now. Okay, and then we'll look at how we would calculate the spring constant from that data. So, you know how yesterday I got like, actually I think it was period 3, I got even more excited about the whole like air column thing? Because like for you guys, I think we got 338 or something like that. Period 3, it was bang on 343. Awesome. I had this like triumphant smile on for like the next half hour. I'm gonna have that triumphant smile on again because this is the data that we get and it just works. This is supposed to be a linear relationship. That's what Hooke's law says. Every single one of those points is bang on the line because they're all 8 centimeters apart. Every time I added 10 grams, okay, we got an extra 8 centimeters. It's perfectly linear. It's exactly what Hooke says it should be. Right? So now what we want to do is use this data to get the spring constant of the spring without just doing each trial and going F equals negative K over X. Okay? We want to average these trials. Now, because my data is awesome, okay, it's all, I could use any one of those points. They're all the same distance apart and it would work. But I still want to average them. Okay? I still want to use the whole graph. So how would I do that? How would I do one single calculation that would get me Hooke's law's spring constant for this spring for the whole lab?
Calculate the area under the line.
Okay, if I calculate the area under the line, I'm multiplying force and distance. That'll get me work, won't it?
Yes.
Yes, okay, so that would be something useful. It's not what I'm looking for here.
Is it the 0.07?
It's close to that. Look at my graph. What's on the y-axis? Distance. Okay, so think about spring constant. The units for spring constant are newtons per meter. That 0.0788 is meters per newton because it's rise over run, right? It's y over x. So the actual spring constant is the inverse of that. That slope is 1 over k. Okay? It's 1 over the spring constant because that's the way we did the lab. Okay? We had force being our manipulated variable and distance being our responding variable. And that's fine as long as we understand that the slope of that line is the inverse of what we want. Okay? So all I have to do is go 1 over this number in order to get my actual spring constant. Does everyone understand what I'm saying? I see a few confused looks out there. Okay? Remember that slope is y minus b over x. In this case, that's going to be meters divided by newtons, and I want the inverse of that. I want newtons per meter. Okay? Now, if you think about this, when I go 1 over this, am I going to get a big number? Bigger.
It's
12.7 newtons per meter. That would make sense. We never stretched that spring close to a meter. Okay? Of course, we never used a newton's worth of force either. Okay? But if we wanted to stretch it by a meter without destroying it, okay, it would have to be a lot longer, obviously. But we would need 12.7 newtons to do it. Okay? So the spring constant of that spring is 12.7 newtons. What are you guys getting? What's that? The exact same. Okay? Everybody else getting around that number? Because we all had the same spring. I mean, within manufacturing, kind of preferences. But okay, we should all get around 12.7, somewhere in that neighborhood. Are you guys getting Daryl? I'm gonna have to have a look at how that one works. Okay. What is everybody else getting? 18.8 repeating? Okay. I mean, the springs are supposed to be the same, and everyone's gonna have some variance in how they read the numbers, right? Like, I just used my video from when I did this during the pandemic so that kids could still do the lab, and I was just looking at, because I took really close-up pictures of it with the phone, okay, so I could really read it well. If you were a little ways away, or the lighting wasn't perfect, or whatever, you might have just been off a little bit on the measurements. Okay? All right, but generally, that's what we should see. Nice linear relationship, okay, on our graph, because that's what Hooke's law says should happen. Okay, everybody good with that? Okay, so this is a little bit of a refresher on Hooke's law, you know, when we're almost done the unit, so that it makes a little more sense when exam time comes. Okay, that was all we needed to do with that. All right, did anyone finish all of the air column questions yesterday? Okay, if you didn't finish all the air column questions, I'd like you to finish them. If you did finish them, I posted the unit exam review package this morning on Google Classroom for the last, what do we got, 15 minutes of class or so here. Maybe have a look over the review package, okay, because I will do a unit exam review Wednesday of next week. Okay, it's the day before the test, just because I gotta make sure we get through everything. Okay, so for the remainder of class, if you're already done the air column questions, have a look at the review package. Okay, and if you're not done the air column questions, make sure you get those done. And I can answer any questions you have in the meantime.